In 1976, NASA ran a life test on Mars. It came back positive. Then NASA walked it back. Two robots on opposite sides of the planet, thousands of miles apart, ran the exact same test and got the exact same result. Something down there was alive. Then a second instrument said no, and for the next 50 years, almost everyone believed it. But a new book says NASA had it backwards all along. So what did that second test actually get wrong? So let's back up to 1976. NASA lands two robots on Mars, Viking 1 and Viking 2. They're not next to each other. They're on opposite sides of the planet, thousands of miles apart. Each one carries a small chemistry lab built to answer one question. Is anything alive in this dirt? This wasn't a quick add-on experiment. Building a working biology lab small enough to survive a rocket launch, a landing, and the Martian cold, and reliable enough to trust the answer it sent back, took years of design and testing before either lander ever left Earth. Whatever these machines found, NASA was going to take it seriously. How do you even test soil for life without a microscope? You don't look for the organism, you look for what it does. The experiment was called labeled release. Here's the idea. Scoop up a pinch of Martian soil, add a few drops of water mixed with nutrients, and watch what happens. If something in that soil is alive and eating, it'll breathe out gas. And that gas was tagged with a radioactive marker so a detector could catch even a tiny whiff of it. On July 30th, 1976, the results came back. Positive. Gas was coming off the soil, fast, exactly the way it would if microbes were feeding. And it wasn't a fluke. Both landers on opposite sides of Mars got the same curve. Same shape, same timing, same strength. Okay, but soil can react to water without being alive. How did they rule that out? This is the part that made scientists sit up. The team ran a control test. They took a second soil sample, baked it at a temperature that kills earthly microbes, and ran the exact same test on it. The reaction died. Then they tried a middle temperature, hot enough to stress living things but not fully sterilize them. The reaction dropped but didn't vanish. That's not what a simple chemical reaction does. That's what happens when you injure something alive. Robert Jastrow, who ran NASA's Goddard Institute for Space Studies at the time, put it bluntly. He said short of literally watching something wiggle under a microscope, the case for life on Mars was about as strong as this kind of experiment could ever make it. So why isn't this the most famous discovery in space history? Because Viking was carrying a second instrument, and that instrument disagreed. It was called a gas chromatograph mass spectrometer, basically a machine that heats up soil and sniffs the fumes to identify exactly which molecules are in it. If life exists in that soil, even dead microbes, you'd expect to find organic molecules. The carbon-based building blocks every living thing on Earth is made of. The machine found almost nothing. Less organic carbon than in soil samples from the moon. And the moon has never had life. To most of the scientists on the mission, that was the tiebreaker. You can't have a biology experiment testing positive in soil that doesn't even contain the basic ingredients for biology. So the yes from the first experiment got overruled by the no from the second one. NASA's official position became no life detected. That view held for decades. Did everyone agree with that call? Not everyone. The scientist who built the labeled release experiment, Gilbert Levin, never backed down. He spent the rest of his career, decades, arguing that his instrument was right and the interpretation of the second one was wrong. Most of the field treated him as an outlier, a true believer who couldn't let go. Then, in 2008, something happened that had nothing to do with the life on Mars debate at all. What changed? A different NASA lander, Phoenix, touched down near the Martian North Pole to study ice and soil chemistry. It found something nobody expected. The soil was loaded with a chemical called perchlorate, about 0.5% of it by weight. That's a huge amount for a naturally occurring compound. Perchlorate is a powerful oxidizer. On Earth, it's used in rocket fuel and explosives because it's so good at ripping apart other molecules when heated. And that detail mattered enormously, because Viking's second instrument, the one that found no organics, worked by heating the soil up to hundreds of degrees before analyzing it. Wait, so the test built to look for life on Mars may have been cooking the evidence before it could ever be detected? If Martian soil is full of perchlorate, then heating that soil the way Viking did would have burned up any organic molecules almost instantly, turning them into carbon dioxide and water before the detector ever got a look at them. A NASA astrobiologist ran the numbers and calculated that even if Martian soil held organic carbon at a concentration of 0.1%, roughly 30 times more than the organic carbon found in soil from the Atacama Desert, one of the driest and most lifeless places on Earth, Viking's instrument still would have reported 0. The test wasn't sensitive enough to survive its own method. So the machine that supposedly disproved life on Mars wasn't actually checking for it correctly. It was, in a sense, destroying the sample and then reporting that the sample was empty. Does that mean Levin was right all along? That's the claim now getting serious attention. Stephen Benner, a Harvard-trained astrobiologist and one of the more respected voices in origin of life research, just published a book making the case that the original 1976 positive result was correct, and that the arguments used to dismiss it back then don't actually hold up under a fresh look at the raw data. His argument isn't trust the guy who never gave up. It's closer to go back to the numbers themselves, account for what we now know about Martian soil chemistry, and see what's left standing. And what's left standing, in his telling, is a positive result for microbial life that got explained away by a flawed control experiment, not disproven by it. If this is true, why hasn't NASA sent something back to just check? That's the part that stings the most. Since Viking, Mars missions have mostly avoided asking the direct question again. Curiosity, which landed in 2012, was built to study habitability, whether Mars could support life, not to test for life happening right now. Same with most missions after it. The Viking no became the quiet assumption baked into decades of mission planning. Look for water. Look for ancient conditions. Don't look for something alive today, because Viking already checked, and Viking said no. But if Viking's no was built on a broken test, that assumption was never solid to begin with. 50 years of caution may have been based on a false negative. So what would it actually take to settle this? A modern instrument, built with what we now know about perchlorates, running a proper labeled release style test on fresh soil. That experiment hasn't flown since 1976, nearly 50 years, and nobody has repeated the one test that actually got a positive result. Does any of this actually matter today, or is it just old history? It matters more than it sounds like. Right now, NASA and other space agencies are working on missions to bring physical samples of Martian rock and soil back to Earth. If Mars is truly lifeless, that's just a very expensive rock collecting trip. But if Viking's biology experiments really were picking up microbial activity, that changes the whole calculation. Bringing home a sample that might not be sterile is a different kind of mission. One that needs quarantine planning, containment protocols, and safety review before a single canister gets opened on Earth. Scientists who re-examined the Viking data after the perchlorate discovery were direct about this. They wrote that Viking's negative result can't be used to justify a sample return or astronaut safety plan built on the assumption that Mars has no life. That assumption was never proven. It just went unquestioned for 50 years because everyone trusted the wrong instrument. If you want to see where this goes, because there's a real chance the answer to "Is there life on Mars?" has been sitting in a filing cabinet since the Ford administration, consider subscribing. It helps me keep making videos like this one.